Hello everyone, myself Ruchi Rathod. Welcome all of you in my channel. Here I am with new topic of quantum mechanics, that is variational method. In this I am going to teach you how to solve the numerical related to variational method. Okay, and what are the steps that you need to follow to solve this variational method numerical. Okay, so all these things I will be teach you in this video. Okay, and later on I will make videos on variational method where I will teach you in detail about the variational method. Here in short I will tell you what is exact the meaning of variational method, why it is used, and what are the steps that you have to follow to solve the variational method numerical. Okay, so first of all, variational method, it is a approximate method which is used to obtain the ground state energy. That is, with the help of we can determine the system's ground state energy. Okay, now the step number one that we have to follow is we have to assume a trial wave function. Okay, with the help of this trial wave function we can calculate the energy. Okay, and after that we will write the expectation value of Hamiltonian. Okay, expectation value of this Hamiltonian, and we solve this, and that is known as the expectation value of energy that we will get. Okay, so first we will take a trial wave function to solve the variational method numerical, and after that we'll write a expectation value of Hamiltonian to solve further with the help of this formula. Okay, now the next, once we got this expectation value of Hamiltonian with this formula, what we will do is we will to get the minimized value of, that is minimum energy value, what we have to do, we have to differentiate this expectation value of Hamiltonian with the variable parameter. Okay, that means after getting the value of expectation of Hamiltonian, we have to derivate this with respect to the variable parameter. Now what is variable parameter is, see, for example, we have a one trial wave function, that is psi of x, which is equals to e raised to minus alpha x. Suppose this we have trial wave function. So here this alpha is known as the variable parameter. So with respect to this, we will get the value of minimum energy. That is, we will minimize this to get. Okay, so to solve this, we will put this equals to 0. Okay, so this is the second step that we have to follow here. Okay, now once we will done with this, okay, so once we will done with this, that is this derivative part, see, once we will done with this derivative part, so here we will get the value of alpha. We are doing these steps to get the value of variable parameter. Okay, so after finding the value of alpha, again we will put this alpha value in the Hamiltonian equation. Okay, and after putting the alpha value in the Hamiltonian equation, we will get minimum energy, and that minimum energy will be greater than or equal to exact energy. Okay, so let's recall all these steps once again. The number one, we have to assume a trial wave function. Okay, and we have to write a Hamiltonian equation, value of expectation of Hamiltonian. Okay, and with the help of this we will solve this expectation value of Hamiltonian. Okay, that is known as the expectation value of energy. Once we done with this, we will find the value of parameter variable parameter, that is this, we will find out. And this we can find out by differentiating this with respect to variable parameter, and we put that equals to 0. So from here we will get the value of alpha, and that value we will put in this equation to get the minimum energy. Okay, and that minimum energy will be greater or equal to the exact energy. So these are the steps that you have to follow to solve the variational method numerical. Okay, so let's start with one example. Okay, it's not much difficult, only the things you have to remember the steps. This is also very simple. Okay, so here the question is, estimate the ground state energy of a one-dimensional oscillator, harmonic oscillator. Okay, we have to calculate here ground state energy of one-dimensional harmonic oscillator of mass m and angular frequency omega using Gaussian trial function. Here we have to use Gaussian trial function to solve this numerical, to find out the value of ground state energy for one-dimensional harmonic oscillator. This we have to do here. So now recall all the steps. Okay, the first what we will do here, we have what, one-dimensional harmonic oscillator. So for that we will write the equation of Hamiltonian, that is this we will write for the one-dimensional harmonic oscillator, that is minus h cross square upon 2m d square upon dx square plus half m omega square x square. Okay, this we have to write the Hamiltonian equation, and here I have given this as a equation number 1. Okay, now what we have to do, we have to take the one trial wave function. Here there is a one Gaussian trial wave function I have taken to solve this. Okay, now here, as I told you, in this Gaussian trial function, this alpha is known as the variable parameter. Now after this, what we have to do is, first we have to find the value of this a. Okay, so this a value we can get by using the normalization condition. Okay, so normalization condition is what, integration of minus infinity to plus infinity psi star into psi dx, which is equals to 1. This formula we will use to get the value of this a by using the normalization condition. So simply what we have to do, after using this equation, that is this equation, we have to put this psi into this. Here as you can see, here we don't have any complex variable. Okay, so here we will take this as it is. So here I have written, instead of psi star, then instead of psi I have written once again this, then dx, which is equals to 1. Now we will solve this. Clear? So here we'll get a square outside. Okay, and then inside we have e raised to minus alpha x square, here also e raised to minus. When we multiply these two, we will get e raised to minus 2 alpha x square, and this dx, which is equals to 1, as it is I have written. So when we solve this, a square as it is, and see, when we have such kind of integration, so instead of this directly we can use the this. Okay, here there is a steps that you have to remember, that is the integration of this. When you will get such kind of value in the integration, that time you can use this. Okay, so when you have such kind of integration, like integration of minus infinity to infinity e raised to minus alpha x square into dx, so you will get root over of pi divided by alpha. Clear? So here what we have, exact we have this value. See here, here exact we have 1, instead of 2 alpha, here we have alpha. So here root over of pi we will get as it is, but here we have written alpha only, na? But here we have 2 alpha. So here we will get 2 alpha. That is what we will get instead of this integration, root over of pi divided by 2 alpha. Okay, a square as it is, and this will be equals to 1. So now from this we can easily solve the value of a square. So a square will be what? 1 divided by this value. Okay, that is this, you can see here. See, this we will get. Okay, when we inverse we will get this. So a square we have got this, root we can write half. Then a will be what? It will be 2 alpha divided by pi. Already here half is there, so here we will get 1 by 4. Clear? So basically this trial function that we have using here, that we have taken here to solve this variational variational method numerical. So here value of a we have got. So now we can write the unknown value, that is unknown value of a we can write here, that we have find already. Okay, earlier it was unknown, but now it is known, we have done. So a we will put here. So what a value we have got? This, and e raised to, see here, a instead of a we will put this that we have got here, and this e raised to minus alpha square we will write as it is, that is psi of x. Now this trial wave function we have got this. Okay, so I will give this as the equation number. Okay, now what the next step is? We have used the trial wave function. Next is to find the value of Hamiltonian. So Hamiltonian equation was this. Okay, so these steps we have done. Normalization condition we have done, so we have to use these steps. Now what we have to do is, see here we will write expectation value of h, which is equals to this. Okay, now this symbol is known as the bra sign. Okay, and this symbol is known as the cat sign. Clear? So in the bra and cat sign form we will write this Hamiltonian here. Okay, then what we will do, the value of Hamiltonian that is we have written here, the value of Hamiltonian that we have written here, this value that we will substitute in this equation, that is here we will substitute. So after substitution part we will get here. Now as you can see here we have plus, so we will separate this into the two form, that is one. First we will write this, then we will write this second one. So first we will write this minus h cross upon 2m, it is constant, we can take outside. Then this like bra psi function with d square upon dx square, and then cat form, this we can write. Now here half m omega square we can we can take outside, and here x square will be inside, we will take this. So I hope you have understood how we got this and this. The constant we have taken outside, and the derivative, which part we have to do the derivative, that integration, that we will take inside. Okay, now for here to get the value of Hamiltonian, okay, here just we have put the value and we have got one equation. Now we have to find out this two to get the value of Hamiltonian. So first we will find out this, then we will find this, okay, value of this, then we will substitute here. So to get this, what we will do is, first we will write this here, that is this. Okay, now this I can write like integration minus infinity to plus infinity psi star d square upon dx square into psi dx. In this form we can write this. Okay, now psi star psi, that is the value that we have taken, trial wave function. Okay, so trial wave function was a e raised to minus alpha square. Instead of psi star we will write this d square upon dx square as it is, and then instead of psi we will write this trial wave function and then dx. Okay, now here a is common, so we can take a square outside, a into a, okay, a star into a, that we will take a square outside. Now here we will get e raised to minus alpha square as it is, and this term as it is. Okay, a we have taken outside. Clear? So now what we have to do is, first we have to do the double derivative of this, then we will multiply with this, whatever answer we will get from here. Okay, so derivative of this, double derivative of this term, we will get this. Here I have shown the steps how you will get the double derivative of this. First I have done the d by dx of this, that is we have done the derivative of this with respect to x. Okay, I have done the differentiation of this with respect to x, so I have got this. Okay, after doing the again, that is double derivative, what we will get? We will get this equation. So when we simplify this, we'll get this one. Okay, so just go through these steps. I'm not going to explain each and every steps of this, because already have done in maths the derivative part. Okay, so go through this, but still if you have any doubt, you can ask me in the comment section. Clear? So this is the value that we have got, the double derivative of this. So now what we will do, we will substitute this here. Clear? And this term will be as it is. Instead of this, we will get this value. So here I have substituted. Okay, see this. Here I have substituted. Clear? Here first plus term I have taken, then minus term I have taken here. So now what we will do is, we will multiply this e raised to minus alpha x square inside. Okay, inside to both the term, the first and the second term. So after multiplying, we will get this term. Okay, 4 alpha square as it is, here x square as it is, e raised to minus alpha square. When we will multiply this with e raised to minus alpha square, it will give us e raised to minus 2 alpha x square. Okay, and when we multiply this with this term, here also e raised to minus 2 alpha square, and 2 alpha will be as it is, minus sign as it is, and the whole term we will write as it is. Okay, now after this, we will solve this further to get the answer. Now this we can split into two parts, one in this part, another one in this part, and in between we'll get minus sign. And here I have taken 4 alpha square as it is constant, we have taken outside, and 2 alpha I have taken outside as this is constant, and here inside we have this term to minus 2 alpha x square. Here also we have it is to minus 2 alpha x square, but here we have x square also. Clear? Now if we solve this integration, it will get that means it will be complicated to solve for us. Okay, we can solve, but it will take too much step if we solve the integration. So what we will do, directly with the help of formula we can use. Okay, that is the integration value we will use here, the math step that you need to remember this. So if we have the integration form, this, that is x square e raised to minus ax square. So for that we will get value half root over of pi and a cube. This we will get. So as you can see here, we have the exact integration. Okay, only the instead of alpha a, we have here 2 alpha, and the minus sign as it is, every value is there. So instead of this, what we will get here, half we will get, root over of pi we will get, but in here we have a cube, that is it, but instead of a, what we have here is 2 alpha. So a cube, that is this cube, what we will get, 2 raised to 3, that is 8, and alpha cube, this we will get. Clear? Now minus 2 alpha, and instead of this integration, as you can see, this is similar to this integration. So we will use this integration formula to solve this. So here we are getting root over of pi by a. So here we have value of a. All values are same except this. Only this instead of a we have here 2 alpha. So instead of a we will write 2 alpha like this. See, and this 2 alpha as it is, this 4 alpha square as it is, this a square as it is, this we have got. Okay, instead of solving the whole integration, what we are doing, we are taking the integration form this to direct solve this integration form. Okay, so we have got this. Now we will solve this further to get the answer. Now what we are doing is, we will put the value of a square, that is this value of a square here. What is the value of a square? see here we have got the value of a square, that is this value we have got. Okay, 2 alpha upon pi raised to half. So this we will substitute there. So see, I have substituted the value of alpha here. Okay, clear? Now this 2 will be cancelled by this 4, so here we will get 2. So here 2 alpha square. Now this pi upon 8 alpha cube, this root I can take right here as a half. Okay, so this step understood. Now here minus 2 alpha here I have written. Okay, this a square will be multiplied to both term, na? So here I have written alpha square a square value. So here also I need to write the a square value, because a square will be multiplied in both the term. Okay, 2 alpha as it is here. Root over of pi upon 2 alpha I can write pi upon 2 alpha raised to half. Instead of root I can write here half. So this we will got. This we will get. Clear? Okay. Now we will solve this further. So now as you can see here, see here some terms will be cancelling each other. Here as you can see here also we have root, here also we have root, that is 1 by 2, 1 by 2. So pi it will get cancel each other. Here alpha, 1 alpha will get cancel, so here we will get alpha square. 2 here when we divide this we will get here 4. Okay, so what we will get here 2 alpha square upon 4 alpha square. Okay, okay, this we are getting in the pi 1 by 2. When that means we are, what we have got here, root over of, see here we have got root over of 4 alpha square, that is 1 upon this. Okay, after cancelling, and here we have 2 alpha square in multiplication. So when we remove this root, what we will get the value? We will get 2 alpha. Okay, clear? That is, instead of root over of 4 alpha square we will get 2 alpha. Now it is clear, and already on the upside we have 2 alpha square. So 1 alpha cancel each other, 2 into 2 it will be cancelled to each other, 2 and 2. So here at this term we will get only alpha. Okay, see here we will get only alpha. Clear? Now see here these two are exact opposite, so they will cancel each other and we'll get here 2 alpha. Okay, so we got these two, alpha minus 2 alpha. When we solve this we will get minus alpha. Okay, that means the value of this we have got minus alpha. Okay, so we have done solving of first term. Now we will solve the second term, that is this we will solve. Okay, so here also first we will write this in integration notation like this. Okay, then we will put the value, that is at this form we can write psi star x square psi dx. Okay, here minus infinity to plus infinity. In this form first we will write, then psi star value we will put, psi value we will put, and here x square and dx. Okay, then here a square we can take outside, then we have inside x square, and when we will multiply this and this we will get e raised to minus 2 alpha x square. Okay, so now to solve this what we are going to do, simply a square we will write as it is. Now to solve this integration again we will use this integration form, because here also we have x square raised to e raised to minus alpha square. This form we have na integration, so we will use this form to solve. So after using this form we will get this answer as I have explained in earlier steps. Okay, so this integration value we will get this and a square as it is. Now we will put the value of a square. Okay, as I have shown you earlier step how to put the value of a square, and then this value as it is, instead of root I can write half. Now we will cancel the terms here, 2 cancel by this, so we will get 4 here, here alpha cancel by this, here we will get alpha. Okay, raised to half, pi cancel each other, so here we will get 1 upon 4 alpha square 1 by 2 as it is. Now when we remove this root, what we will get? 1 by 2 alpha. Okay, and here 1 by 2. So what we will get? 1 by 4 alpha. So the value of this, what we will get? X, we will get 1 divided by 4 alpha. Okay, brass eye of x square of cat sign, we will get 1 upon 4 alpha. So we have got both the values. Clear? So now we will substitute this 4b equation and equation this, that is 4a equation, this value we will substitute in the equation this 4, that is here we will substitute this value, here we will substitute this. So for this we have got minus alpha, and for this we have got 1 upon 4 alpha. Okay, so this we will got, here we have got 1 upon 4 alpha. Clear? So we will substitute here. So after substitution part, see, I have written here what you will get. Okay, by substituting the values, what you will get here, wait just a minute, this value you will get. Okay, the first term you have got minus alpha, second 1 upon 4 alpha. Clear? Now this minus minus becomes plus, so h cross square alpha divided by 2m plus here 4 into 2 8 alpha as it is m omega square. So this value of Hamiltonian we will get here. Okay, now we have taken the trial function, then we have done with finding the equation of Hamiltonian. Okay, now what we have to do, we have to use the third step, that is what we have to find the variable parameter value. To get the variable parameter value, what we have to do is we have to derivative this Hamiltonian, expectation value of Hamiltonian with respect to variable parameter, that is alpha, and we put this as equals to 0. This is the third step that we have to do. So instead of expectation value of h, we will write this whole equation here. Okay, that equals to 0. So what I have written, d by d alpha of h cross square alpha divided by 2, I have separated in two parts, plus d by d alpha of this, the second term I have written here. Now we take the constant term outside and we'll do the derivative. So here h cross square upon 2m is constant, we can take outside. What is the value of differentiation of alpha? It will give us 1. So here we will get 1. Okay, now here m omega square upon 8 I can take outside. Now 1 upon alpha I can write alpha inverse. So derivative of alpha inverse, what I will get is this. Okay, and this term I have written as it is, then this term I have written as it is, this minus sign I can take here, and then m omega square upon 8, this alpha raised to minus 2 I can write 1 divided by alpha square. So I will get this term, that will be equals to 0. So now what I can do is I can take this whole term on the right hand side, so it will becomes with positive sign. So now by doing the cross multiplication, here we will get 8 alpha square h cross square, here we will get 2m into m omega, that is 2m square omega square. So alpha square will be equals to what? This term I will write here, and 8h cross square will goes to down on the right hand side. Then to get the value of alpha, we'll put root over here, that is we will get this value. Okay, and here we have divide here 2 by 4, so here we will get 2 by 8, so here we will get 4, that is this. So here we will get m square omega square upon h cross square. From this we have got. Now if I remove this root from here, so what we will get here, alpha, which is equals to, when we remove this root, so we will get here m only, here omega only, here when we take 4 outside of this root we will get 2, and when we take h cross square outside of this root we will get h. So this value of alpha we will get m omega upon 2h cross. So I have given this as a equation number 6. So once we got the value of alpha, what we have to do is we have to put this value of alpha in the equation this, that is in the equation number 5. So after substituting this value in equation number 5, what we will get? See, earlier our equation of Hamiltonian was this. When we put the value of alpha, we will get the s correspond to m as it is. I have written alpha value, I have written here 1 upon 8, I have written here alpha, 1 upon alpha is there na? So alpha value is what? M omega upon 2h cross. So 1 upon alpha will be what? 2h cross upon m omega. Clear? So this we will get into m omega square as it is. Now see, here m, it will cancel each other. Here we will get only h cross. So here we will get h cross omega upon 2 into 2, that is 4. This we will get. Here by 2 we will divide this, so we will get 4 here. M cancel each other. Here we will get 1 omega. Clear? That is, here we will get 1 omega and here omega is cancelled. So h cross omega divided by 4. This we will get here. Clear? So here we are getting the exact same term. So here we can take h cross omega upon 4 outside. So here we will have 1 plus 1, that is 2. So that means this we will get. So when we divide this, we will get 2. Okay. So that means we are getting h cross omega by 2. This is our minimum energy that we have got here. By minimizing the Hamilton expectation value of Hamiltonian, we'll get h cross omega upon 2. Okay. As now I know what thought comes in your mind is, it is very long numerical. Okay, and you can't do it, but you can easily do it. Just you need to do the practice. Okay, you need to remember the steps what you have to follow. This is very, very simple. Okay, the simply once again I'm recalling all the steps. First, I have written equation of Hamiltonian for the one-dimensional harmonic oscillator. Okay, the first step what you have to do, you have to assume the trial wave function. Okay, here if the value of, in question sometimes the value is given, but if the value is already, the wave function is given in question, but most of the time you have to assume. Okay, that as you can see here, we have asked you to use the Gaussian trial function to solve. Okay, but in sometimes in question the wave function is already given and you have to use those wave function. Okay, so here we will find the value of a. This is the first step. Then our second step is what? We will write the Hamiltonian, expectation of Hamiltonian, and to get the value of expectation of Hamiltonian. Okay, so here we will get in this form, but it is not a complete one. So first we'll solve this, then we will solve this. Whatever value we'll get of this two, we will substitute here to get the value of Hamiltonian. Clearly? So here, once we got the value of Hamiltonian, what we have to do is see this step. That is a step number 3. Here also, what this we have got the value of Hamilton, equation of Hamiltonian. So now the third step is what? We have to do the derivative of this expectation value of Hamiltonian with respect to variable parameter, and we put this equals to 0. So from here we will get the value of alpha, and once we got the value of alpha, we will substitute in this equation to get the minimized value, to minimize this. Okay, so after substitution part we get, see here I have substituted, then we will get the minimum energy value, that is h cross omega by 2. So only 3 steps you have to do. Once again, assume trial wave function. Then second step, write the Hamiltonian equation. Okay, then third step, to minimize Hamiltonian equation, what you have to do is you have to do the derivative of Hamiltonian with respect to variable parameter. Okay, once you got the variable parameter, you will just substitute in the Hamiltonian equation and solve this to get the minimized value. Okay, so you have to follow these steps to solve the question of variational method. Okay, so I hope you have understood this numerical. Okay, But if you have any doubt regarding this numerical, you can ask me in the comment section box. Okay, so और अगर आप लोग को कुछ है कि कोई न्यूमेरिकल का आंसर चाहिए तो आप कमेंट सेक्शन में वो न्यूमेरिकल सेंड कर सकते हैं. I will try to solve that numerical. Okay, so if you have understood this, please like my video, share my videos and subscribe my channel. Okay, thank you.